Hello everyone, welcome to my another live. I hope you all doing well, and I'm Hiba with you. And this live is about new project ZKWASM. So Gateway launched the 285th launch pool JKWASM USDT or JKWSM to earn airdrops. And Gateway launched the 85th launch pool JKWASM stake USDT or JKWSM to earn airdrops. And thank you so much everyone for joining my live stream. It's my pleasure that you all joining here. Thank you so much everyone. Okay, so here we launch the 285th launch pool JKWASM. User can stake USDT or JKWASM, earn 500,000 JKWASM airdrop for free. Okay, and staking period July 2025 at 12 to July 29 2025 at 12 UTC. Total staking reward 500,000 GKWASM. And Gate launch pool allows user to stake early. You can stake your asset before the project officially launches, ensuring you start earning reward immediately once mining begins. Reverse distribution: the system will distribute token reward to users' spot account every hour based on the proportion of assets staked by each user. Newcomer exclusive staking pool: only new users who sign up after July 20, 2025 at UTC are eligible. How to participate: log into your Gate account and complete identity verification. Navigate to launch pool, hold at least 0.1 USDT or 1 JKWASM and then click stake. And Gate user, hi Gate user, thank you so much for joining my live stream. How are you, Gate user? Okay, project information. Delphinus Lab is the core development team behind JKWASM, the first open source virtual machine enabling zero knowledge proof generation for WebAssembly. WASM, it enables verifiable off-chain computation and supports modular roll-up architecture. The ecosystem includes a JK native launch pool, Real use cases like verifiable mini games backed by top tier investors such as Binance Labs. And Mahdi, can you please comment here in English? I didn't understand Arabic. Please try to comment here in English, Mahdi. So, backed by top tier investors such as Binance Labs, Hashkey Capital, Mirana Ventures, and 7x ZKWASM is positioned as a core JK infrastructure layer for scalable, trusted Web3 application. And Mahdi, I'm fine. How are you? And that is the website link. And GitLab's investment disclosure: GitLab did not invest in JKWASM nodes with low. Sorry, Git Launchpool is an innovative staking and airdrop platform where user can stake GT, BTC, Ethereum, USDT, or other token to earn hourly airdrops of hot and new coins with low entry barriers and high APR. It's the ultimate platform for effortlessly capturing and number 3, please adhere to the relevant rules of the event. Any cheating behavior is prohibited. Any cheating behavior will result in disqualification of the reverse. Where any discrepancies arises between the translated version and the original English version, the English version shall prevail. Gate reserves all right to the final explanation. This event is not affiliated with Apple. Users in the United Kingdom and other restricted location cannot access the services. See the user agreement for further details on restricted location. Risk warning: number 1, the project team does not guarantee that token price will not be lower than its initial sale price. Please invest with caution and don't invest beyond your financial capacity. The crypto project is still in its initial stage. Factor including the operation and underlying technology of the project and other related regulatory activities might contribute to significant risk. Advanced technical and financial knowledge is required to understand and evaluate the inherent risks of crypto asset investment. The market volatility is high and the price of a token might fluctuate drastically due to technical, regulatory, and marketing factors. Users may not be able to withdraw all the purchased token due to technical issue of the project or gate. And then that is all about gateway to crypto. Trade over 3,500 cryptocurrencies safely, quickly, and easily on Gate. And then JKWASM LAUNCHPOOL. So Delphinus Lab is the core development team behind JKWASM, the first open source virtual machine enabling zero knowledge proof generation for WebAssembly WASM. It enables verifiable off-chain computation and supports modular roll-up architecture. The ecosystem includes ZK native launchpad for deploying problem D apps, targeting real use cases like Mirana Venture and 7x ZKWASM is positioned as a core JK infrastructure layer for scalable, trustless Web3 application. Start time 22/7/2025 18 and in time 29/7/2025. And project info introduction. JKWASM total staking reward 250,000. Mining period 7 days. Total reward 500,000. Total staked 11 lakh to 396,359.97. Participant 3,448. Price pool hourly capture 1,488.09. Individual hourly reward capture 28 2,000 208.33 and APR 257.23. Individual staking capture 100,000. And JKWASM Hub. WASM WebAssembly is an open standard binary code format close to assembly to leverage the power of JKWASM. Developers need to compile application using a compiler that supports WASM as backed bytecode. Currently, Delphinas Lab provide demonstration in C, C++, Rust, and assembly script with comprehensive SDK support. And JKWASM is a JK emulator that proves the correct execution of WASM application. It serves as a trustless adapter between rich application running on WASM runtime and smart contract on various blockchains. The mission is to provide Web2 developers with a concise toolset to leverage the power of Web3 in their application. On-click end-to-end and GitHub to chain deployment platform that enable gasless chain agnostic deployment for scalable user-focused application integrated with the ecosystem trio. And JKSM Explorer. JKWASM Hub is a hosted cloud service for finding and sharing JKWASM application images. It provides automated providing and batching services and JKWASM token distribution, total supply and current circulating supply. Launchpad proof network deployment at governments. So long patch take to earn early access, reward access exclusive project. Okay. Delphinas JKWASM book. This repo contains documentation about the JKWASM and can be seen live at See the Book Live. The mission of Delphius Lab is to provide Web2 developers with a concise toolset to leverage the power of Web3 in their application. The JKWASM serves as a trustless layer between rich application running on WASM runtime and smart contract on-chain. WASM is an open standard binary code format similar to assembly. Its initial objective was to provide an alternative to JavaScript with improved performance for the current web ecosystem. Benefiting from its platform independence, front end flexibility can be compiled from the majority of languages including C, C++, AssemblyScript, Rust, etc. Good isolated runtime and speed comes closer to the speed of a native binary. Its usage is arising in distributed cloud and edge computing. Recently, it has become a popular binary format for users to run customized functions on AWS, Lambda, OpenAir, Azure, etc. The idea of ZKWASM is derived from ZKSNARK, zero knowledge, which is combination of SNARG and zero knowledge proof. In general, the adoption of ZKSNARK usually requires implementing a program in arithmetic circuits or circuit-friendly languages that forms a barrier for applying on the source code. Applying it on the bytecode level of virtual machine and implementing a ZKSNARK backed virtual machine. In this work, we take the approach of writing the whole WASM virtual machine in ZKSNARK circuits of so that existing WASM application can benefit from by simply running on the WASM without any modification. Therefore, the cloud service provider can prove to any use that the computation result is computed honestly and no private information is leaked. Docs include tutorials for the following audience: beginners to get familiar with developing WASM based application that runs in ZKWASM virtual machine, and specification for ZKWASM host circuit. Sophisticated roll-up application builder that would like to leverage the ability for ZKWASM for their own application roll-up. Circuit integrator that would like to use WASM as a glue language to connect different ZKP circuits for more customizable scenarios. ZKVM builders that would like to use a core minimal set of WASM bytecode to build their own ZK virtual machine. This document also provides the information regarding the ZKP circuit design, proof batching and aggregation, proof structure of continuation, execution, WASM or host, circuit integration and WASI support. This book is a web and being constantly updated. ZKWASM for beginners. Delphina's lab provides solution for trustless computation and an application and this document is written to describe basic usage of ZKWASM to run WASM based application in command line. We assume the reader knows the basic of the following: compile Rust application using cargo basic of makefile, configure environment variable, okay, and WASM tools. And Mahadi, thank you so much for joining my live stream again. And quick start, JKWASM's philosophy is trying to provide a customizable code stack that user can interact with the JKWASM virtual machine at different levels. This quick start is tutorial that assume user runs JKWASM VM as an integrated product that takes in a complete WASM image, inputs for this image, and then generates an execution proofs after running it. Generating a JK proven application whose proof is deployment ready is broken down into three stages: step up phase, proof phase, deploy phase. And in the proof phase, web assembly image is processed by JKWASM to generate JKSNARK circuit for the application itself. The proof phase generates a zero knowledge proof corresponding to the application execution against a guest and host virtual machine. Finally, in the deployment phase, a verification contract for the application is deployed on an EVM compatible network. Moreover, before we start to generate proofs in ZKWASM, we need to prepare a WASM image that is supposed to be executed. And step up and build the ZKWASM binary. To build and run this project, require the Rust compiler. Install Rust up with this and verify the installation with this Rust version, and then clone the JKSM repo and move into the dictionary. Build using cargo CPU version, build GPU version. The recommended way of running JKWASM prover. Also, if you do not have a powerful GPU, you can compromise the performance by this, okay. And prepare WASM image. Since ZKWASM runs WebAssembly application that are supposed to run in ZKWASM have to be compiled into WASM WebAssembly. WASM is designed to be a portable compilation target for programming languages, enabling deployment on the web for client and server application. A wide range of languages can be compiled into WASM with varying degrees of support. Some of the most notable languages include C/C++. These are the most well-supported languages for compiling to WebAssembly. Tools like Mscript 10 are used to compile C and C++ code to WASM. Rust has robust support for WebAssembly. It's often chosen for WASM project due to its performance characteristic and safety guarantees. AssemblyScript, a variant of TypeScript AssemblyScript, is designed to compile to WebAssembly. It's a good choice for developers familiar with TypeScript or JavaScript. And Go has experimental support for WebAssembly. While not as mature as C/C++ or Rust, it is still a viable option. Python, Ruby, and PHP, these languages have experimental or early stage support for WebAssembly. Tools and runtime are being developed to compile these languages to WASM, but they may not yet be suitable for production use. Native Kotlin can target WebAssembly, allowing Kotlin code to run in the browser. The ability of compile a language to WebAssembly largely depends on the availability of a suitable compiler to toolchain. The WebAssembly ecosystem is rapidly evolving, and new tools and languages are constantly being added to the list. Generate WASM C or C++ code. Following is a trivial piece of C code, jkmain.c, that compares two inputs, one from the public input and the other from the private input, and requires that those two inputs are equal. To compile the above piece of C code to WASM, we use the Clang15 as our C compiler and set the target binary to be WASM32 and put the above makefiles in the same folder as jkmain.c and type. Will give the desired WASM file output. WASM, this file can be then used to run in JKWASM VM to generate proofs once inputs are provided. Also, more C2 JKWASM program SDK can be found in Delphina's Labs JKWASM C repo. Generate WASM from Rust code. Here we use Rust as a reference language. Thus, all examples are coded and compiled using WASM bind chain. WASM bind chain is a tool and library for facilitating high-level interaction between WebAssembly WASM modules and JavaScript. It's particularly prominent in the Rust ecosystem, but its principles can be applied to other language that compile to WebAssembly. And Get User, thank you so much for joining my live stream. And this is not a market analysis, it's a project, so I can't tell you anything about market get user. Okay, to use WASM bind chain in your Rust project, you can simply put it in your cargo tom as follows. Suppose that we use jkmain.rs as the main entry point of your application. We can start our application as follows. Okay, and file output after WASM code generation. Once you have complied your C and Rust code, the directory should look like that. Makefile output.wasm jkmain.c/jkmain.rs. The file output.wasm will be input image for jkwasm as setup phase below, and set up jkwasm circuit, the main with the WASM bytecode beginning generated. We can start set up the circuit of the VM. In the setup phase, an application as a WASM image is used as input to JKWASM to generate a JKSNARK circuit for the application. The setup phase generates the output wiki data for the image, which is a circuit that commits is constant column. There are two modes to set up JKWASM: the uniform circuit mode and the image specific mode. The uniform circuit mode, when the JKWASM is run in the uniform mode, its circuit is designed for all WASM images, and the bytecode of the WASM image are witness of a certain column of the JKWASM guest circuits. When a proof is generated using the uniform JKWASM circuit, one need to provide the image commitment to the verifier to verify that certain proof is generated for a particular JKWASM image. Within the directory with the program built using environment setup, run the setup JKWASM with the input WASM use image from above as follows. And get user, should we hold or sale? Thank you so much for your comment, but that is the project live, so I can't tell you anything about market. Okay, get user, can you understand? And the single image mode, when the JKWASM is run in the single image mode, which is the default mode, and Deluxe07, thank you so much for joining my live stream. And Samuel, hi Samuel, how are you? Thank you so much for joining my live stream. And Ali Dry, thank you so much. But I didn't understand Arabic. Please try to comment here in English. That will be better for me. I'm also fine. Samuel. And Agot Cano 82. Hi. Thank you so much for joining my live stream. And here, who is commenting here in Arabic, please try to comment here in English. I didn't understand Arabic. Okay, the single image mode. When the ZKWASM is run in the single image mode, which is the default mode, its circuit is generated for a specific image, and the bytecode of the WASM image are fixed values of a certain column of the ZKWASM guessed circuits. When a proof is generated using the single mode circuit, one do not need to provide the image commitment to the verifier, and only the proof for that particular image can be verified using the generated verifier. Within the directory with the program built using environment setup, run the setup ZKWASM with the input WASM use output.wasm from above as follows. And Agot Cano Edu, thank you so much for joining my live stream again. And this produce the output files in as the default mode is more friendly for beginners that might only focus on a particular application. The following content will assume the default mode is enabled. However, all examples should also work in uniform mode. And the continuation mode, when you are running a WASM image with unbounded execution trace, you needed to use the continuation mode of ZKWASM, which will split the execution trace into slice and generate proof for each slice. And proof WASM execution, proof generation of a single execution. In the proof phase, the web assembly interpreter outputs two traces, the WebAssembly bytecode as the execution trace and the host API call trace. This record the order of the host API calls and their output. The combination of the two traces ensures the host call trace is in the same orders as the execution trace, including the same input arguments. To generate a single proof using ZKWASM using the WASM image generated from the C code above, we simply run the ZKWASM VM with that image and provide a public input and a private input to it. And in the above command specifies the host API state we would like to use. Since our application does not rely on any special WASI function, and tells the prover refer to folder for all circuit specific data. The argument specify the output folder for proof result together with some intermediate files. After executing the command, it should produce the following file in the output directory. The overall information of the proofs is stored in the ZKWASM.loadinfo.json, which looks like the following. A few things is ZKWASM.loadinfo.json are worth mentioning at this stage. First of all, the test-version circuit finalized data file contain all the information about the circuit. The test-version X instance data is the public instance for the proof. The test-version X transcript data is the execution proof generated for the output version with given inputs. XXX JSON files in the trace dictionary are execution trace for debugging purpose, and the external host table is the trace of the host function calling into. In this example, we do not invoke any host APIs, thus the external host table is empty. Please refer to ZKWASM host circuit for more details. The process of proof generation requires reading the process of proof generation requires reading the wiki, which is implied by the output circuit finalized data and k params that is generated in the previous setup phase. These files in the params folder will be needed in the proof batching. Everyone, thank you so much for joining my live stream. And Momo 14632, thank you so much for joining my live stream. But dear, I didn't understand Arabic. If you know English, please try to comment here in English. So sorry. And proof verification. The verification of a proof generated by ZKWASM is done using the command line argument in below bash script, which is executed from within a single verification run can be done by, where JKSBIN is the dictionary of ZKWASM. And aggregate batch proof. Suppose that we have generated a guest proof with its loading info and stored in the following directory: makefile output.wasm params k22.params testversum.circuit.finalized.data testversum.jkwasm.config output traces testversum.loadinfo.json. And also, suppose the overall information of the proof is stored in the ZKWASM load info JSON, which looks like the following. তুমি যাই একটু কমেন্ট করতে পারো না? হ্যাঁ, কি? I'm formal. Here, for simplification, we use ZKWASM batcher to batch the above proof into a small one. Suppose that your project dictionary is the following. Okay. And host built-in function. WebAssembly host function refers to a function that is defined in the WebAssembly module itself, but it is provided by the environment in which the WebAssembly code is executed. These functions are crucial for WebAssembly models to interact with the outside world, as WASM on its own is quite sandboxed and limited in what it can do directly. Here are some key points about WASM host function. Interaction with environment provided by the host environment imported into WASM modules. Custom functionality. In summary, WASM host functions are a crucial part of the WebAssembly ecosystem, enabling WASM module to interact with their environment in a controlled and secure manner, thus extending the capabilities of WebAssembly beyond its sandboxed context. In the ZKWASM, we provide a wide range of predefined host function to ease the burden of building sophisticated application. We divide them into three major categories: IO related host function, constraint related host function, predefined host function with external circuit support. And build a roll-up application. This document is supposed to be complete reference for ZKWASM user that would like to make their own roll-up application. Following topic will be covered: the architecture of a reference implementation of ZKWASM rollup application, the proof generation architecture, customize and define your ZKWASM by extending host APIs, customize your proof generation via proof batching script, define settlement protocol, and deploy your rollup verifiers. And circuit design introduction. WASM is an open standard binary code format close to assembly. Its initial objective is to provide an alternative to JavaScript with better performance in the current web ecosystems, benefiting from its platform independence. Front end flexibility can be compiled throughout the document. We use the nation a to specify a variable of type a F to specify the number field, and Fn to specify a multi-dimensional vector with dimension n. We denote by a. B is function type from A to B and use for function composition. Moreover, we use Gij to specify the value of the and MICS and Q and A. Why pick WASM as the native bytecodes? Our ZKVM. Hello, mine. Thank you so much for joining my live stream. Okay, WSM runtime is native supported. Runtime is browser and serverless application given the support of. And Jessica Zara, welcome to my live stream, Jessica. Thank you so much for joining here. And WASM is a major alternative to Ethereum bytecode. WASM has a very concise but flexible specification. And WASM is a bytecode that has regular evaluation managed by World Wide Web Consortium W3C. It means the WASM adopt itself quick than stable bytecode like EVM to fit the need of modern Web 2 applications. And JKWASM, JKSNARKWASM emulator, Sinca member IE and Hongfei Fu. And introduction. WASM or WebAssembly is an open standard binary code format close to assembly. Its initial objective is to provide an alternative to JavaScript with better performance, independence, front end flexibility. It can be compiled from the majority of languages including C, C++, assembly script, Rust. Okay, so performance benchmarks. Benchmark for single segment. Unlike a traditional VM in which instruction might have different execution time, the main cost of the JKWASM is the evaluation of each polynomial represented by the column of the table 13 and 14. The total number of rows of the witness table is JKWASM as a power of 2. The trace size denotes the total instruction included in the execution trace. The synthesis time is the time to generate all the witnesses needed, and proof time is the time And conclusion and further work, we represent ZKWASM, a WASM virtual machine that leverages the technology of JKS and ARK. As far as we know, we are the first to present a novel way to implement the semantic of WASM virtual machine in arithmetic circuit. Using JKWASM, we can deploy several services. And that there is Dr. Gokyang Lee, member IEE, received the BS, MS and PhD degrees from the Taiwan University of Technology, Shanghai Jiao Tong University and Japan Advanced Institute of Science and Technology in 2001, 2005 and 2008 respectively. He is now an as associate professor with the School of Software, Shanghai's Jiao Tong University. He worked as a postdoctoral research fellow at the Graduate School of Information since 2008 to 2009. Okay, Sinko Gao. Okay, that is all about IEE Explore. So thank you so much everyone for joining my live stream, and that was our Crypto Champion. Hi, thank you so much for joining my live stream. How are you, Crypto Champion? Why not just use LLVM with bytecode as a binary format? Crypto Champion, good work dear. Thank you so much, Crypto Champion. The LLVM compiler infrastructure has a lot of attractive qualities. It has an existing intermediate representation and binary encoding format, bitcode. It has code generation, backend targeting many architecture, and is actively developed and maintained by a large community. In fact, PNRCL already uses LLVM as a basis for its binary format. However, the goals and requirements that LLVM has designed to meet are subtly mismatched with those of WebAssembly. WebAssembly has several requirements and goals for its binary format. However, the goals and requirements that LLVM has designed to meet are subtly mismatched with those of WebAssembly. WebAssembly has several requirements and goals for its instruction set architecture, ISA, and binary encoding and portability. The ISA must be the same for every machine. Architecture change only in ways that can be kept backward compatible. Small encoding. The representation of a program should get user and what is this? Dinal too. I don't know. What is your name? Hello. Thank you so much for joining my live stream. I can't spell your name. I'm so sorry. And minimal. The behavior of progress should be as predictable and deterministic as possible and should be the same or architecture. A strong form of portability requirement stated above. None of these problems are insurmountable. For example, PNCL defines a small portable subset of the IR with reduced undefined behavior and a stable version of the bitcode encoding. It also employs several techniques to improve startup performance. Note that this decision applies to use of LLVM IR as a standardized format. LLVMS, Clang, Frontend, and mid-level optimizer can still be used to generate WebAssembly code from C and C++ and will use LLVM IR in their implementation similarly to how PNSCL and IMScript tend to do today. So thank you so much everyone for joining my live stream, and I'm Hiba with you, and that was our ZKWASM project. Gateway launched the 258 launch pool, ZKWASM stake USDT or JKS2 earn airdrop. So thank you so much everyone for joining my live stream. Now I will close my live, and tomorrow I will come with my another live. Till then, take care and Allah Hafiz.